Good morning. This is Young Dan here once again for another show on Young Dan Radio. I have a very interesting guest with me today, Mr. Val Martin. He's from the county of Cavan in Ireland, and today we're going to be talking about wind energy. And starting off, I was of the belief, and I have spoken many times as the usefulness of wind energy and how it's going to be something that should be utilized in the future. But on having studied this a bit more closely, Val has raised some significant issues here with regards to energy. So I might have my mind changed for me today. Hello, Val. Are you out there?
Hello, Declan. Greetings from Ireland.
Thank you very much, and thank you very much for coming on the show. Now,
You're welcome.
I came across you when I was speaking to some people from Fiesno, and I was looking into a few things that they were proposing, and one of the things had to do with local money issues and bartering systems, which I thought was a good idea, and it is a fact of a good idea. But also, as you know, they are big into wind energy, and I decided to look into it more closely, and that's how I came across you. Now, you are making two assertions here, basically, that are very, very important, and your assertion is that the economic cost of this wind energy does not add up to what they're claiming, and in actual fact, it could be a very, very, very great negative cost. And to add injury to insult, you also ascertain that the amount of emissions that it, in actual fact, will end up reducing is minimal and may actually be negative as well. So before we start on to those two very things, will you just tell us a bit about yourself and how you became interested in this subject?
Yes, Declan. Well, I was born in a nice valley near Kingscourt in County Cavan, and my father, P.J. Martin, he was fairly well known in the area for repairing alternators and dynamos and parts for tractors and all that. People would come to him to get them fixed, and he would be telling me, or he would tell me all about the way the different currents work, and I would pay little heed of him as a youngster, but it's only when I get older that I remember how significant some of it was. And he had a wind turbine on the tree at the back of the house, and he had a water wheel in the river, and that was back during the war years. They used to say that it worked, but when I asked him why it worked, he said he also had a petrol engine driving it as well. It was a battery system. But when he took it down when we got the power, but later, as I was growing up as a teenager, myself and some friends built a hut in the garden, and we installed the turbine again on top of a tree, and we thought we'd have light and plenty of fun. It was like a tree house. But we found to our cost that when the wind blew hard, it would blow the bulbs, and when the wind would die down, we had no light. So we put a battery in with a car regulator, a relay, a 12-volt thing, and the battery would have the effect of giving it a little longer power. But when the wind would die down, it would eventually subside, and we'd be in the dark again. So it gave me some bit of an insight at an early age into the limitations of wind power, which later was dismantled. I still have it at the house. So that's basically it. Well, then I have high ground. I'm farming at the moment, and I have high ground in East Cavan, and I was approached to allow a company to install wind turbines. And my first reaction was, because I had a bit of an interest in business, was, well, maybe I'd try putting them up myself and gain all the benefit from them. But before doing so, or whatever I was going to do, I decided to examine the sustainability of wind farming, because I had a doubt about it. There was a lot of positive things in the media, and I checked it out, and that's where I come to the views I have formed at the moment.
Okay, now I should point out as well to the people that's listening. So you were a self-taught man. You don't have any academic qualifications, but I would point out that your son is a qualified graduate and electrical engineer, and you've discussed this with him as well.
He is indeed. Paul is as an electrical engineer. I have a degree in business studies from the IPA in Dublin, but it's not in that discipline. I would be the type would go to exhibitions in England on model engineering and all that, people who mess about in the garage and that. So that's about it, yes.
Very good. Now, before we start on today, there's a couple of basic terms that we want to set out so that everybody will be able to understand them. And first of all, to give us an indication on how much power is being used in Ireland at the moment, and how much might be needed. And we'll keep it more or less at round figures. I have been reading that the power usage basically maxed itself out there at just under 5,000 megawatts um, of energy. Is that correct?
Yes, well, the power companies in all systems, they must match the generation to consumption. The voltage and the frequency is a function of the two. It's balanced. It's like a horse pulling a plow or something. There's a certain pull and it's both ways. So at the moment, up to, let's say, about 2 years ago, the generation was about 5,200 megawatts. According to EirGrid's present report, it's gone up in 2009, though it may not all be connected, to 6,171. Now, this is what they call dispatchable generation, which in their parlance means that it's capable of being turned on and turned off, as opposed to, in other words, they're sure of it. They can know when they have it. That generation is due to rise to 2016 to 9,191. So that's 147% of an increase that's planned. Some of this is already online. The exact place where we stand at the moment depends on hydro and a number of other things, but it's somewhere around 6,171, maybe rising next year to 7,000, and then gradually going up to 9,1, which they hope to have at 2016.
So at the moment it's about 6,1, as you say. That's the amount of electricity they have available. But the actual amount of being used is only about less than 5,000 at the moment. Is that correct?
Yes. On the peak draw, that's when the maximum draw comes. They publish figures giving it here from 2001 to 2009, and it rises from roughly three. It rises from about 3,995 in 2001 to 4,900 in 2009, and it was roughly the same this year. So it stands roughly at a little under 5,000 for the peak draw. But the average draw, that would be maybe at the present now on a Monday evening when there's a sort of a certain amount of uses, but not too much. It's around 3,000 megawatts that would be drawing at the moment. It would rise then in the early evening, and it would drop off drastically at night then to a lot less, maybe about 2,000 megawatts at night of an ordinary night. Weekends, holiday periods would be less. And then coming up to Christmas on very cold weather, when everyone's cooking and factories are running and people are trying to get everything ready, it can go way up. That's when the peak draw is. And as I say, the average there during that period is around 4,900 megawatts.
Okay, so the bottom line for the listener anyway is that there's plenty of excess capacity at the moment without adding any either fossil fuel or any wind turbine generation onto the load.
That's exactly my point. We have a nice round figure. There is some upgrading and some improvement and making plant more efficient. That's going on. That all has been done in the system. But yes, you're right. I cannot understand why we need to increase by 48%, particularly in the present downturn that we have.
Well, now let's just put a value on this proposed increase. I've been reading here that, and I've read other places similar figures, but I've been reading here that the cost that they intend to spend on this wind energy and on the upgrades is 12 billion euros, which in round figures comes out at 3,000 euros per person, or 15,000 euros for a family of five. A lot of money in today's climate of need.
Yes. That's the figure that's given, and it was given on a recent television program here as around 12 billion. But if you quantify or put a price on these turbines, a 2 megawatt turbine costs around 1.7 million. There's 100 lorry loads. I think it's 760 cubic meters of concrete, 4,000 tons of concrete in the base of one. And then there's all the ancillary stuff and roads and all the rest. I believe it could run into about 26. You must remember, here in Ireland, nearly every project we ever constructed, let it be road, rail, or anything else, it never came in on budget. There may be one or two exceptions, but it nearly seems to be par for the course that it always is greater than it's actually planned. So I would say, as a conservative amount, that is the amount. It could be a lot more, Declan.
So you're saying that this entire project could cost, in the ballpark, in the broad range of what NAMA is, maybe a bit less, but in the general ballpark of the amount of money that's being spent on the banks?
Well, now the banks, yes, the banks. I think is coming in a good around 56 billion or something like that. I have to admit that I'm not too well up on it. It was originally said to be 34 billion. I would say this could be somewhat less, I would think. What it is probably nearer to is the NAMA thing. Now, the banks is the money actually going into the banks, but NAMA is an asset management agency for ghost estates that were built and borrowed by the banks and which can't be sold, but there's no market, and they're trying to manage them and buy them at a knockdown at a cheaper price and eventually sell them on. And this is the idea the taxpayer is paying it. Interestingly, one of our economists here, well-respected Colin McCartney, I saw him recently say on television that he could.
Well, it's a huge figure, and if it's only 12 billion, it's still a lot of money. Yeah, another thing I think we'll be discussing later, but the most important thing of the whole thing is can you tell us briefly about the 20% cash reserve over and above what might be used that companies use as basically insurance?
In the generation of electricity all over the world, virtually except including Ireland, Europe, the United States, power is alternating current. And Edison was the famous man who tried to produce this by dynamos, in other words, direct current, and he discovered he needed the power station every 2 miles in York. A man called Nikola Tesla countered him on that and said, no, heat current fed into transformers and transmitted over very long distance. So all our houses and all is transformed. Now, Declan, just to remind me again your question.
Yes, the question is that the electricity supply board, whatever one it is, cannot afford to have any outages. So they continually run at 20%, have spare backup excess capacity running at all times, which they can bring on at a moment's notice. And they cannot function without that. Otherwise, if there was a blackout, it would be catastrophic. You cannot afford a blackout, if at all possible, in an industrialized country.
Yes. I now remember we're talking about reserve capacity, and the reason I mentioned about the different type of current is that by and large nobody has ever managed to store this. There's a huge debate that we could in the future, but it hasn't been possible to store it. And because of that, the power stations all over the world, they know, let's say this evening, that they'll need maybe 4,000 megawatts at peak period. So they have their plant up and running at that stage. However, there's always the unforeseen thing. A typical example would be if there's a good program on television and everybody runs in and puts on the kettle at the one time. That would drop voltage and frequency. And in order to cope with that, they need plant running in reserve, ready to connect to the mains. And that's about 20% usually. And as you rightly say, it's an insurance. It's the same as you would put a little extra petrol in your car if you're going a long journey or anything. It's very important to have that as a part of all transmission systems. But the wind industry claim that reserve can be used to take up a slack when wind dies down or it has to stop during a gale. And it has been described as trying to share your house insurance with your neighbour. You can guess how that would work.
Yes, so the companies have to, there's a cost of doing business, of course, insurance, and it's the same thing.
It's added on to our bills and we accept it as a necessary thing. It's part of the security of supply, and we have to pay that little extra to have it. If our country was one that people didn't mind and it wasn't an important issue, and if the lights went out it didn't matter, then you wouldn't have the same level of security of supply. It wouldn't be too important. Actually, we had a blackout, what about it? But in a country like ours, you can have awful problems if you have a blackout. For example, fridges containing food can go out. You could be in a factory and the machinery could stay on and the lights could go out and all that. So it's not really on in any Western or modern economy to have lights, to have the blackouts.
Well, seeing that you did mention bills there a moment ago, I see that 1,300 people a week are being cut off from their electricity supplies due to the fact that they're simply not able to afford to pay it anymore. And this is basically a life and death situation for a lot of people. And the last thing we need is more expensive electricity than we need to be paying for.
Yes, this was reported on the radio. I heard it myself shortly before Christmas this year, and it's a frightening figure. It comes from the fact that the bills have gone up, and we also have the welfare and the income of